All right, welcome everyone to our educational webinar, and thank you guys for joining. Today's webinar topic is NX routing harness, a smart way to create 3D wiring design. My name is Mason Wu from AT Engineering. I am based off in our San Diego office. I'm very excited to be here today, joined by Mike Senedek from Siemens, who is a subject matter expert of NX software. He will be the one presenting the topic today. Before we dive into the webinar, there are some housekeeping notes. All attendees will be muted throughout the webinar. If you have any questions, please type them into the chat and we'll have Mike and our team answer them at the end of the presentation. You will also be able to ask him directly if you like. We'll unmute you at the end. Let us know. This webinar will be recorded and be available on our website and on our ATA YouTube channel. Before I hand this to Mike, just want to give a quick overview of AT Engineering about who we are and how we might be able to support your team. So most people recognize ATA as an engineering service company. Our core founders have been working together for almost 40 years, and we have vast experience providing high-value engineering services, focusing on test and analysis-driven design. Majority of our businesses are in aerospace and defense industry, which accounts about 70%-ish. But we also work in other industries as you can see here. About who we are, ATA is an employee-owned small business with a full-time staff just over 200 people. Most of us have an advanced engineering degree, as you can see on the right. 7 regional offices across the US. As for now, and as I've mentioned before, we have years and years of experience focusing on design, analysis, and test. This includes everything from structural design, structural dynamics, thermal, vibroacoustics, to CFD and more. Test-wise, we are one of the largest leading independent modal test group in the US. We have a lot of experience flying our team to the testing article location and conducting GBT. Aside from our engineering service business, this is how most of you joining the webinar today know about AT Engineering. We are a Siemens VAR, value-added reseller, who not only sells the product, but also provides software support and training to our customers. What we really focus on product is the one that helps design, analysis, and test. For example, NX, which is the topic for today, is for design. VMAP CCM for simulations and testing. We are one of the Siemens partner in the US that can provide SimCenter testing hardware and software. So because we sell what we use, our customer really appreciate our familiarity of these tools, and it shows in our hotline support. Every time you call, you're speaking with an engineer that uses the software and actually have the software on their computer and understand the problem. In addition, we teach a variety of classes, primarily dealing with simulation, and we generate all the Siemens training material for the Nastran software. So a lot of time, if you want to get a Siemens Nastran class and you go up to the website, you will find that locations either in Denver or San Diego, because those are the 2 locations that ATA teach the classes for, and Siemens is the one taking the registration. Finally, last slide before I hand it to Mike, I want to encourage people to visit our website. It has our hotline support information. It's one of the unique advantage getting your Siemens software support from ATA, and some free resources, including like past webinars, VMAP APIs, white papers that you will be able to download. All right, with that, let me hand it to Mike, today's speaker. He's a partner solutions consultant and team leader at Siemens. Over 26 years of experience, he's a subject matter expert in NX CAD and NX CAM, Solid Edge, and SimCenter 3D. All right, take it away, Mike.
Great, thanks, Mason. All right, so hopefully you guys can see my desktop okay?
Yes, I can confirm.
Great, thank you. So welcome everyone. Thank you for your time. Thank you, Mason, and then the ATA team for inviting me today to speak with you. So our agenda for today is really to intro the NX multidiscipline portfolio and really focus our time around the NX routing harness product. We'll talk a little bit about the capital and NX routing integration. We'll look at a customer success. We'll finish out with how can you get started with the tools that I'm going to show you today, and then just close out with our value message for moving to this solution. So if we take a look at the multidisciplinary portfolio, which NX delivers, everybody thinks about the mechanical side of what we do, but we also have areas for electrical, process, and automation. And so today's tool will actually showcase how we connect to ECAD tools and be able to design and build out 3D electrical wire harnesses in our design. And so it's really to help extend that comprehensive digital twin. So if we take a look at the routing product, there are two components to how NX brings this solution to marketplace. So there's a common framework in the middle called the routing base application. And what we'll demonstrate as we go through, you'll see things about creating the path, how do you do the part placement and selection, library management, design rule validation, those types of things. And so that's a core piece. So in NX, then we have the electrical side, which is the harness and cableway and that type of design. We also have the mechanical side. So we're not focused on that today, but there's also things like the piping and routing and steelworks and HVAC and those types of things. So the routing base is common amongst both of those, and then the specific disciplines that we add on top of that, that's what those particular solutions help you with, right? So there's additional functionality. And so we'll walk through that today and get an understanding of what's in base and what does the electrical and the harness side provide to you. So one of the first things is the ability to qualify parts, right? So you're going to have connectors and different electrical components that you want to put into your harness. And so those might be models that you've developed yourself. Those might be models that come from the internet, from a vendor, those types of things. And so it's a very easy process to bring those into NX and then go through the qualification process. And so what we do there is apply the different connection ports. That's what you'll see in the little arrowheads that are positioned on the component. You'll put the pins, so whether you have a series of them, that information is what you're going to feed in. Also some things like the additional length, a wire may just go from the connector to the other connector, but also those extensions, that type of length, so that you get very accurate cut lengths for your harnesses. And so different characteristics, things like that you want to add in, all of that is done through this qualification process. So let's take a quick look at that. How does that work? How easy is that for your designers as you start working with the system? And so whenever we're designing harnesses inside, whether this electrical control box, a vehicle, an airplane, a space capsule, you use our application menu, right, to access it. So we have the mechanical and electrical, and then here we have the specific disciplines that you would actually select. So in this case, for today, we're working in the harness. And so you'll see that there are some things which are the base, which are like the path and the stock and the parts, and then there are things for the harness itself. And so in this case, this particular plug that I have, I went out, downloaded it, the solid body from the internet. You're able to go in and develop, again, the ports. This is where the wires are going to connect, and then from the harness. And then also, as you go through, you can put, in this case, we just have one terminal, but if you had multiple, it would define all of those pins on that particular connector or device. And so another piece of this, as you're working, these elements we want to be able to visualize in the assembly. So we use our reference sets, and that really is a filtering at the assembly level what we see. So you can see here with the socket that we have, we're using that reference set. Now you see both the part and you see the port that we'll actually use to connect things together. And it literally is that simple. It's very fast as you go through there. but you do want to have those, and you'll see what the benefit of qualifying those parts as we get downstream to create the centerline path, and then things like making modifications and stuff. But that's an important first step. Then as you go, you'll want to be able to do the part placement. So just as we've qualified, now when you bring them in, we can actually do this within the routing application. So it's a bit different than when you add parts in just regular NX assembly modeling. We can go through the part placement here, and because of these smart ports, it's going to actually connect it correctly into your design, right? So there may be a positioning that you have to have with the electrical component so that they go together correctly. All of this is done inside of the routing application. So we'll place those parts, and you'll see how you can control how it's oriented and things like that right from in here. We'll also talk in a moment about the reuse library. So the reuse library, this is where this information is contained, and that way everybody knows go to a single source and use that information as they design their wire harnesses. So when you're in there, there's ways to search for the data. So you can look at specific, information about that particular part, and it will help narrow down that search. Now, we do have a sample library of components that you can use, but it's really just as examples. That's something that you will work to build out those libraries of the parts that you normally put into your electrical harnesses. So let's take a look at how that works as well. So what we'll normally do with a harness is you have a subassembly that you're going to work in the context of. So as you're in there, you'll also see then as we were working in the routing application, as we're working in harness, one of the things are to place parts. So you can place them in, and this takes us right to the reuse library. So from here, if we wanted to, again, use any of the sample parts, you could. You can see here, it works exactly like you would any of our other reusable components. They've already been qualified, that way you can drop those in. Also, you can have libraries of your parts. So you can either put them into this container, or you can have your own. And so I'm going to show you one where I just created my own container. I have some electrical components that I want to place in, some connectors and such. And so you can see them right from the menu, select the ones you want. And now what you see is, instead of having to do all the assembly constraints, I just have to pick the port. And now here you can see how you can lock that into position so that it is correctly attached for your harness. So once that information's in, then the part's in there, you're good to go. You're ready to move on to the next stage. Okay. So again, you can kind of see how with that harness, you see the components, you see a lot of those ports, then that will be important for the next stage of creating the centerline path. So path creation, this is, to me, one of the key reasons why you would use the routing application. In modeling, you can create a spline, you can create curves, lines, arcs, segments, and that, and you could sweep a tube along there. But when you start to move components, you start to do things, those don't maintain tangency. They do a lot of different things if you just use the modeling application. With the routing-based capability, we have some very specific tools to help you get this correctly and quickly develop that. So you'll see the different things for the spline path, for the heel path, and things like that. These are very efficient methods, and they make sure that your parts stay connected specifically to these routing harnesses. And so it's just a much, I think, better and easier way for your designers to create these harnesses and develop that path through a complicated assembly in the context. Also, one of the things that we have as part of the harness add-on is design rule checking. So inside, we already have specific checks that'll look for, hey, if the bend radius of that wire, are we pulling that too tight? And that would violate certain lengths all of those things, it would check those. If you want to extend that, that's something you can use our NX Open API to change those rules and do other things that you would like to with that. So that's also an important piece as we go in and start to develop these harnesses. So if we move to that next stage, let's go ahead and take a look at that. So now the first portion, and this is all in the routing base functions, are to build those center lines. And so here, the user, all you have to do is select those ports, the multi-ports that we have. And so you can see that as we're building, it's showing you right on the screen, what do we have, where is it located? And so, again, you can use the quick select. That'll get you to the routing ports. It is an object by itself that you can select from. What you also have are things for if you wanted to put slack into the design. You also have things that if you want to set the length to a very specific length. So sometimes it'll come out at 45.178. You might want it to be 45.25 inches, and you can enter those values and it'll set the spline that length. Also things that, we're not going to have just one centerline path. You're going to have maybe one main branch, and you want other elements to split off from that to other devices. So we have tools there to be able to subdivide up your spline, your main spline. What you notice there is then that stays tangent to each other. So as you move components or you do things with the harness, that will stay connected, right? It'll be appropriate and it won't mess any of that up. If you did that with some other curves in modeling, it would be much harder for you to maintain that. You'd have to do a lot of extra work. And here, that's eliminated for your users. So you'll see just going through, connecting up some of the different elements here. So using the heel path is nice because all you do is give it a start and an end. You can give some extension initially at each end of that, and it goes ahead and routes that appropriately between those. So the spline path is really good. Obviously, you can create linear paths, and the heel path is one that really comes in handy when you're developing the harness. So you can see here just a couple different examples. We're going to a couple different devices on the panel. And again, it's just a combination of those functions to create your entire harness center line. So with that, then at this point, you have everything you need. If this was, the mechanical designer doing some initial layout, they know the devices, they know where they want. One of the things you could do at this point is, you can make different modifications. So not only the start and end points, but anywhere along there, you can add additional, and you can use the drag handles with that. So we can adjust and move this to exactly what we need, make sure we're moving around, we're giving clearance, we're doing other things like that. But the last step then, if I wanted to, at this point, I have everything I need. If I would like to do the space reservation is a nice one, where you can use that just to say, look, I need basically this size. I want to make sure I keep everything else away from that. You could apply the space reservation stock on top of this centerline path. And that's while maybe the electrical engineers are still continuing to put out, how many wires, what gauge, that type of information. We could use that to hold the shape of the harness and the location and everything that we need, so that as we put in other objects, we're not, breaking up the path, or we're not intersecting that path as we go on there. But that's the first step for the path creation techniques. And so those tools, I think, are critical in helping your designers do this as easily as possible. So then once that information is done, you're going to want to then make the connection. So your electrical engineers, they're using their 2D layout tool. They're picking the devices, they're picking the wires, they're doing all of that on their side. We want to be able to read that information into NX. So again, that's an electrical engineering tool. We can read those files. They're text-based files with information, and really we can adapt and align the formatting of that information. I'll show you an example of those in a minute. But what's nice about this is then I can read that into NX. And now not only will we have that centerline path, but we'll actually have the details for, what are the components, what are the pins, what are all the right connections, and then we actually calculate that bundle diameter. And so that is what you'll see inside here in a minute. They're able to create that and have the realistic digital twin of the harness inside of NX in 3D. So these are a couple examples of the files for the net list. There's a component list. So think about that on that one panel where I was putting those two gray parts in. They're the same component, but you have to have a unique identifier so we know where to route that to. And so that's what the component list does. It says, okay, I might have 3 of these components in there, but how do we know? So we give them unique identifiers. That could be, J1, J2, P1, P2. That will help us when we make the connections. Then the connection list is, okay, from those unique components, what are the pins? What is the gauge of the wire? What's the color of the wire? That type of information, which again comes from your ECAD type software. So let's see how those steps work here. So we have both a component and a connections navigator. You have a ribbon bar then that controls that information for setting the properties, reading it in appropriately. But it's very simple. Once you set that, you're just going out and grabbing that particular file. We're going to import that textual file into NX. So again, you'll see a little bit different later on when we show how this is done with our own tools, our ECAD tools like Capital and Capital Essentials. So here again, the netlist file, I'm just going to that location to grab those text files and read that in. So here's what you see. There's the connector ID and the actual NX part name. So that is the part name that we have in here. So you do want to make sure what you're calling it in your ECAD and what we have in NX, matches up. So it'll automatically make that connection to those. If it shows here, there were a couple that needed manual. This is where we had, say, duplicate parts. So we just wanted to know which one is P2, which one's P3. It visually shows the designer. You're going ahead and making those selections there. Then on the connection list, this is, again, all about the wires themselves, the gauge of wires, the colors of the wires, all of that information. That also is in a separate text file that we'll read in. And then once we automatically connect that, you'll see the 3D harness. And those are the things to make that a reality. And so you can see there's some really good information in this navigator we'll talk about in a second. So from here, once we have it, you can literally route the information from component level. You can do it from pin level. And what you see is, the user is notified, oh, hey, something's missing here, right? So there's one area that didn't get connected. Well, why is that, right? So we'll be able to diagnose what happened there. But you can see it has the right colors of the wires, the white, the green. The light blue then that you see, that's the calculated diameter of the harness. And then here also I'm showing where did we miss? Well, I didn't actually have a centerline path from the main branch over to that new part I added. Also in the navigator, you can see things like what's the actual length and what's the cut length of the wires that are in there. And that's something that a lot of manual work is normally done. For many companies, they wait to do that. They don't necessarily do that in CAD. And so those are because they go out and they run spools of wire and they cut it and they measure and they do those types of things. But here we can do that digital twin, within the NX environment. So that gives us a look at, how hard is it? Those two files we read in, we understand what the language is between the ECAD and the MCAD. And so then you can create the 3D wire harness. So then finally, as we go, what about changes? What about updates? That's fine. You can pull that information back in. It will update. We can make changes to the path. We can move changes to any of the connectors or any of the clips or any of those things like that. we can modify and update those without having to restart. And so that's a real big thing, is that collaboration between your electrical and your mechanical. So as we may run into changes, we can do that. So let's take a look at just that last piece then. So that new part that I placed, I either forgot or maybe I did that after the fact. You can go back in then at any point, use the heel path or spline path to create the center line. And it's as simple as then just tell it, go ahead and route that. So again, we have one single wire coming from that. You see the color, you'll know it'll update the diameters of the wire harness itself. And then things like moving connectors, moving clips and things like that, because of that port that's on there, the smart port, we can use that then to dynamically update the harness as we're going. You can see there, I didn't have to do any rework. I just was able to move that and update accordingly. And so the same thing I think we showed earlier, we moved center spline path. You can click on it at any point and make it and adjust it to where you need to go from there. Again, really quick, painless ways to make modifications to the harnesses. So with that, that really takes you through what are some of the key benefits. Why would you want to use the NX routing package versus just modeling? A lot of it is with the qualification of the parts and placing them in. You know, it's an easy, quick method to add them. You have the path creation tools, again, which I think are one of the biggest things for this. The biggest benefit to having is to help you with that. How do we route these through a complicated assembly? Definitely those design rule checking. So if you saw in my demo, I didn't specifically do anything to make it, you know, come up or pop up. But if you're working and you make that violation, the menu comes right up to the user right when they do it. So it's interactive checking behind the scenes, and it'll notify them. And then again, just the ability to, you know, set it up so that it fits your needs, right? So we're not pigeonholing you into any specific area with routing. We will have, and we can use all the data. So whether those connectors come again from online or ones you've modeled, things like that, we can easily incorporate those into the design. So with that, that transitions us a little bit to the Capital and NX integration. So if you have an ECAD tool today, if you have an Altium, or you have, some people use, you know, like AutoCAD, they make just 2D drawings and they put symbols in that, but it doesn't have a lot of the automatic intelligence. They can use that in spreadsheets. Any of those methods, we can bring it across, but we wanted to showcase what you can do with Capital, right? So how can that integrate to the NX routing? And so the power here is by having all of these and managing the libraries of the 2D parts, the 3D parts, by having that interaction between the two products, there's a much tighter connection, right? So you'll see some live probing between the ECAD tool and the MCAD tool, and the passing of that information. So instead of, like I showed you, where you had to manually go and grab the file and read in the component or connection list, here that information is, you know, by one user pushing a button, it automatically sends that from Capital into NX, and then the length of the wires is pushed from NX back to Capital. So just some things that normally are disassociated with other tools and how you have to go through that process. So again, why is that important? It really comes down to, you know, reducing errors, making sure we're doing the right thing at the right time. So here's just an example of how this works. And so just like you saw me working within the harness inside of NX, same thing here. We're working with this particular wire harness in the door panel. And so with that, you have all the things that we talked about. And so with the Capital, we have a connector that the user can set. And same thing on the Capital side, they can turn that on. And now we have a live link between the two products. So when we set the bridge, where am I working? I'm working on the door harness. What you can see is in my component navigator in NX, I'm able to bridge that and pass that information right to it. So right there, we have all of our components, we have their unique identifiers, and we're ready to go ahead and then go ahead and automatically route everything with the connection list. And so from there, you see it knew the wires, it knew all of that. And so as we go, you'll see that live cross probing. When I touch something in Capital, it's highlighting in NX. In the navigator and on the screen, you see what's the connector, what's a specific wire, those types of things, and you can confirm and check that out. So that's what we're seeing there. Then the other is because, you know, the CAD is where you're actually getting the length. So when we do this in the 2D layout in ECAD, you don't really tell it what's the length of the wire. We're actually going to feed that back from NX. And so that's the same thing. Having that live connection, I know exactly what that length is. What I've created in the mechanical side, I can then read those values back into Capital and go ahead and generate that. So really helpful to have that tight connection between the two as we collaborate between your electrical engineer and your mechanical engineer. So you can see that information is read directly in. So this is the benefit of having both of our tools to be able to do that. So one other thing then is, as you get to the manufacturing of the wire harness, you usually want to create the form board drawing. And so NX routing harness has a very rudimentary tool for form board, but it's really better to be working in the Capital. So it will take that 3D wire harness, flatten it out. That's what you see on the left-hand side. It will take those, flatten it out. It will show the right orientation for each of the connectors, because as you manufacture that, you want to make sure you rotate and clock that in the right spot so that when we go to plug it in inside the vehicle, the aircraft and such, everything is oriented properly, right? So again, cross probing between the flattened harness in 3D and the flattened harness in 2D. Again, very important as you're going through to that next phase of from design to manufacturing. We want to make sure we've done everything correctly there. So that's kind of a round trip of information. Start with your 2D layout in ECAD, create some of your paths, and then import that information. And here we see the direct connect. And then once you have that 3D harness, the manufacturing, you go back to a 2D layout for that they can use a pin board, print that out, and put that into manufacturing. So that just gives you a little bit of an idea of the interplay. You know, again, NX routing harness plays well with many ECAD tools, but I think we have the benefit, if you are using our tool Capital or Capital Essentials, we can provide some higher level benefit and connectivity when you collaborate on those designs and have any design changes. So with that, just the last piece on looking at customer success. I think any of our customers that are using, in this case, this was Siemens Infrastructure and Logistics, but you know, there's many other customers from the auto and the aero side. It really is reducing those physical prototypes. It's reducing that built by hand, right? Going out, having to take wire, run it, check it, put things together, doing it manually. It's really where this particular tool and solution is helping our designers and really speeding that process along. And so it really ultimately gives you a much better comprehensive digital twin of your product by having this level of detail virtually and done within the NX environment. So to close out a little bit then is, how do you get started? What does it take to get the product, how to learn the product, set it up, those kinds of things. And so there's two options really. So if you have one of our mock bundles today, you can purchase add-on modules for this. So there is a routing base. So for Mach 1, you would need the routing base and the routing harness, those two add-ons to do what I was showing today in our demonstration. If you have a Mach 2 bundle or higher, those particular bundles actually already include the routing base. So all you would need to add would be the routing harness functionality. And that was really to do the component connection list, to do the rules violations, those types of things. That was the routing harness piece. And so again, those are available as an add-on module to any of your bundles. Another option then is number 2 is using our NX design tokens or value-based licensing. And so with that, you really should have 100 pack of tokens in order to do this, because if you have a Mach 1, you would need both the routing base and the harness. So you would need 25 tokens to run the base and 73 to run the harness. So that would take us up to 98 simultaneously tokens in place for that particular designer. If you do have the Mach 2 or higher, then you only need 73, but you'd still need that 100 back. You'd have a little bit of leftover for other functions within our value-based licensing. So those are the primary methods that we can offer you, one or two, depending on what you own today and what you might be looking to add to your capability. The main thing I talk about, the difference, why would I do the add-on versus the token design? For some users, if that's what they do day in and day out, they're doing a lot of routing and creating those harnesses, and they're in there the majority of their time, then the add-on module makes sense. If it's a couple different users and at different times you're going in, you're doing a lot of other work on the electrical panel, or you're doing your design and then you only do sometimes that you're going in to do routing, then the tokens might make a little more sense. So it's more casual usage versus a more of a full-time usage between those two options. So here's just a quick look at some of the things I did, what was in the routing base and what was in the routing harness. So again, we kind of mentioned that the component and connection list is there, the auto routing and bundling tool and the design rules. Those are some main things. The ability to, on the left-hand side, create the paths. Those were the key things in the routing base, and then also things like qualifying and doing those functions. You can do all of that, even up to the space reservation, right? As I'm just putting that initial stock on top of that. So those are some things to keep in mind. So you have one or the other. You can get so far with routing base, but ultimately you want to finish out with the routing harness. And so things, how do we start to understand what's going on? Definitely the NX documentation is a good spot to start with that. It has both the electrical and the mechanical information in there, so you can use that as a way to get used to it. If someone was interested in the piping and tubing and those things, the routing base would still be that central to do the paths. So once you learn one with routing base, you can apply it to each side of the mechanical or electrical. But there's some good information inside of the documentation. This is available to everyone for free. As you're working in NX, if you hit the F1 key, or if you just open up the documentation from NX, it'll take you right in and you can review this information. The other side is from a training. So the on-demand, so our learning memberships inside Accelerator Academy, we have the NX Design Learning Membership. So with that, it's not just the routing that you get all of the NX lessons and tutorials, but specifically in there are things just like I went through. So how to qualify parts, how to place them, creating your segments, assigning components and connectors, working with the different information inside of there. And it goes through, there's a number of lessons that you have that you can work from. So this is definitely an important piece of it, so that you get going successfully and work through the tools that are in there and gain the most benefit. So with that, then, it really is, could you do some of these things with just modeling? You can, but you're doing a little bit more brute force in order to do that, whether you use the spline command and put a tube on it or sweep a shape. When you use the routing, it really does increase your productivity for your designers. They're able to create those paths easier. We know we're connecting to the electrical information, so we know the bundle diameters are correct. We can do interference checking, all of those types of things from there. So with all of that, it really, and confirming, right? Do we have the correct information in? Do the rules validation? All of those types of things. That's the value add by purchasing the module or purchasing the tokens. That can really help make a difference for your business. So with that, I will turn it back over to Mason. And if there are any questions in the chat, or if you had any now, you could add those, and we'll take those at this time.
Thanks, Mike. I think there's one question in the chat, but I think Brandon answered them.
Okay.
Yeah, he's asking about, once you define the starting point, path, and endpoint, can you constrain the wire length? And also, due to material flexibility, can you control the band radii?
Yes. So one, the length you can. So when you're in that creation menu, you can actually tell it, it'll give you, hey, I put it from here to here, and it had those additional decimal places. I wanted to round it off. You can do that. That's right in that path creation menu, so you can control that. The second part of that, then, basically, can you repeat that? So it was definitely the length, and then the other was what part of that?
Due to material flexibility, can you control the band radii?
So when you're doing the spline, you're not really controlling the bend radii with that. You could put additional points onto the spline. The bend radii would be more when we use the linear segment and put an arc or a blend on the corner. We can size that accordingly. We can control that, diameter to the ratio, and control it that way. But when you're doing the spline, not so much controlling that bend radii, but when you do the linear segments and put the bend corner on there, we can control it there.
Gotcha. Cool. Yeah. If you have a specific question you want to ask Mike directly, you can raise your hand. We can unmute you to ask that. And that's the only question I see here. All right, I don't see any other questions. We can close this out a little bit earlier. Thank you again, Mike, on the presentation. Very good job on the NX routing and the options to get the license and capability-wise. We will have the material uploaded to, we'll have the recording uploaded to the YouTube. Unfortunately, the first part will be without my PowerPoint slides, but you will have the best part, which is Mike's presentation on the second half. So we'll get that uploaded to the YouTube channel, and we'll also have the slide deck ready. So cool. Thank you guys for joining today. Appreciate your time. Thank you, Mike. Thank you, Brendan, again on the presenting this webinar.
Sure thing. Glad to help. And if you have any questions, obviously pass that through to the ATA team, and we can get in touch.
Sounds good. Yeah, the video will be available on the AT Engineering YouTube channel. Correct, Mark. All right. Thanks, guys. Thanks again. Bye.
Okay. Bye, everyone.